Protocol architecture, the common language and LAN technologies. Need for protocols. Protocols are a set of rules and conventions. By enforcing that communicating parties adhere to a common protocol, communication is made possible. Protocol determines what is communicated, how it is communicated, when it is communicated. A network architecture is a structured set of protocols that implement the exchange of information between computers. Protocols used in network communication also define message encoding. Message has to encoded before T's and decoded after received the signal. Message formatting and encapsulation. Agreed the format and encapsulate the info identifies the sender and receiver rightly. Message timing, flow control and response timeout. Message size. Long messages must be broken into smaller pieces to travel across the NTK. Message delivery options, unicast, multicast or broadcast, known as elements of data communication protocols. Example, sending a letter Bob's mailbox, Bob Alice ma mailbox. Postman logical flow of information. Acknowledged service, unconfirmed service, acknowledged service. US mail L.request L.indicate L.indicate L.confirm US mail L.request L.indicate. Protocol architectures. There are only few protocol architectures that are relevant today. OSI reference model TCP/IP protocols suite. OSI reference model. The OSI model is a guide for developers and vendors to smooth the progress of developing communication products and software programs that will work in co-op. Once you understand the model, you can then understand which protocols and devices will be compatible with only another. The OSI model defines 7 layers: Layer 7 application layer, Layer 6 presentation layer, Layer 5 session layer, Layer 4 transport layer, Layer 3 network layer, Layer 2 data link layer, Layer 1 physical layer. Interconnection media. OSI layers. OSI layers and encapsulation. OSI model in a switched communication network. Layer interaction. OSI 7-layer model: host router, router host application presentation session transport network link physical network link network link application presentation session transport network link physical hop by hop end to end host. A tour of the OSI layers. Application layer. Layer 7 applications, protocols, and services that interface with the end user using network applications, file transfer, web surfing, emails, virtual terminals that controls the interface with users. Application, presentation, session layers are usually implemented together instead of using laying architecture. Everything is application specific. Example, file transfer, electronic mail. A tour of the OSI layers. Presentation layer. Layer 6 receives data from L7 in the form of numbers and characters, converts to MAC in understandable format, controls the encoding and decoding of data, data compression, data conversion into application format, encryption/decryption. L6 performs 3 basic tasks: translation, data compression, and encryption/decryption. A tour of the OSI layers. Session layer. Layer 5. When a computer connects with a server, before establishment of a sessions, the server performs authentication, username and password, allows users on machines to establish sessions between them. Authorization. When you access the file, you are /not authorized to access the file. Session management and synchronization. Major functions include managing dialogue. Session layer determines whether traffic can only go in one direction or both directions at the same time. Example, RPC. A tour of the OSI layers. Transport layer. Layer 4. The basic function of the transport layer is to accept data from the session layer, split it up into smaller units, if needed, pass them to the network layer, and ensure that the pieces all arrive correctly at the other end. Facilitates end-to-end communication between multiple applications simultaneously. Ports. The transport layer also determines the type of services, connection-oriented or connectionless. Transport L involves segmentation, error control, flow control, TCP, feedback, UDP, no feedback, flow control. With the help of transport L, the mobile informs the server to downgrade to max 10 Mbps. When the server sends at 5 Mbps, informs to upgrade up to 10 Mbps. A tour of the OSI layer's network layer. Layer 3 routes the information in the network, e.g. IP is a network layer implementation which defines addresses in such a way that route selection can be determined. Performs routing/switch packets out of the correct interface, forwarding, logical addressing, IPv4/v6, path determination, RIP, OSPF. Maintain quality of service, QoS, connectionless end-to-end networking. Unreliable, best effort, if packet gets lost, network layer doesn't care for higher layers can resend lost packets. Devices, routers, multilayer switches, and wireless routers makes routing decisions. How can the packet be sent closer to its destination? Forwarding and routing tables embody knowledge of network topology. Routers can talk to each other to exchange information about network topology. A tour of the OSI layer's data link layer. Layer 2 provides reliable transit of data across a physical network link, bundles bits into frames and moves frames between hosts on the same link, often also a definite source and destination link layer address, e.g. Ethernet MAC address. Some link layers detect corrupted frames while other layers resend corrupted frames. Function framing, physical addressing, flow control, error control, access control. A tour of the OSI layer's physical layer. Layer 1 converts bits into electrical or optical signals, moves bits using voltage, light, radio, etc. Bits are defined by voltage levels, or similar physical properties, transmits these signals over the hardware communication medium. Function, physical characteristics of interfaces and media, representation of bits/no concept of bytes or frames, data rate, synchronization of bits, line configuration, point-to-point or multipoint, physical topology, mesh, star, ring or bus, transmission mode, simplex, half-duplex, or duplex. TCP/IP protocol suite, a set of rules, protocol, that defines how two computers address each other and send data to each other, is a suite of protocols named after the two most important protocols, TCP and IP, UDP, RTP, etc. The TCP/IP protocol suite was first defined in 1974. The TCP/IP protocol suite is the protocol architecture of the Internet. The TCP/IP suite has 4 layers: application, transport, internet, and network interface layer. Example, file transfer, host A, router, host B. Encapsulation in the TCP/IP suite. TCP/IP protocol suite, different names for packets at different layers: Ethernet, link layer, frame IP, network layer, datagram. TCP, transport layer. Segment terminology is not strictly followed. We often just use the term packet at any layer: frame, datagram, segment, packet. Comparison of OSI model and TCP/IP suitability. OSI TCP/IP protocol data unit devices Internet protocol suite 7 application data HTTP, DNS, DHCP, FTP, SSH, SNMP, BGP, RIP6 presentation 5 session 4 transport segments TCP, UDP3 network Internet packets router multilayer switch, wireless router IPv4, IPv6 ICMP, OSPF, iGroup, RIP2 data link network access frame switch bridge, NIC, wireless access point MAC, ARP, Ethernet, CDP, HDLC, SONET/SDH1 physical bits hub, NIC. Encapsulation decapsulation. Encapsulation. Name one function of the network layer. LAN technologies. Cabling straight through, unlike devices, e.g. router to switch, PC to switch, crossover like devices, e.g. router to router, PC to PC, switch to switch, PC to router. Console, rollover, console port, e.g. PC serial port to DB adapter to console port. Physical layer. Repeaters distance limitation. In local area networks, electrical signal becomes weaker as it travels, imposes a limit on the length of a LAN. Repeaters join LANs together. Analog electronic device continuously monitors electrical signals on each LAN, transmits an amplified copy. Physical layer. Hubs joins multiple input lines, electrically designed to hold multiple line cards, do not necessarily amplify the signal. Very similar to repeaters, also operates at the physical layer. Hub. Limitations of repeaters and hubs. One large shared link, each bit is sent everywhere, so aggregate throughput is limited, e.g., 3 departments each get 10 Mbps independently, and then connect via a hub and must share 10 Mbps. Cannot support multiple LAN technologies. Does not buffer or interpret frames, so can't interconnect between different rates or formats, e.g., 10 Mbps Ethernet and 100 Mbps Ethernet. Limitations on maximum nodes and distances. Shared medium imposes length limits, e.g., cannot go beyond 2,500 meters on Ethernet. Link layer. Bridges connects two or more LANs at the link layer. Extracts destination address from the frame. Looks up the destination in a table. Forwards the frame to the appropriate LAN segment. Each segment can carry its own traffic host. Bridge. Link layer. Switches typically connects individual computers. A switch is essentially the same as a bridge, though typically used to connect hosts, not LANs like bridges. Support concurrent communication. Host A can talk to C, while B talks to switch A, B, C, D. Dedicated access and full duplex. Dedicated access. Host has direct connection to the switch, rather than a shared LAN connection. Full duplex. Each connection can send in both directions. Host sending to switch, and host receiving from switch, e.g., in 10 base T and 100 base T. Completely supports concurrent transmissions. Each connection is a bidirectional point-to-point link. Bridges/switches. Traffic isolation. Switch breaks subnet into LAN segments. Switch filters packets. Frame only forwarded to the necessary segments. Segments can support separate transmission. Hub switch/bridge. Segment. Advantages over hub/repeaters. Only forwards frames as needed. Filters frames to avoid unnecessary load on segments. Sends frames only to segments that need to see them. Hubs broadcast everything out, all ports but port of origin. But switches only broadcast if MAC address not in CAM table. Extends the geographic span of the network. Separate segments allow longer distances. Improves privacy by limiting scope of frames. Hosts can snoop the traffic traversing their segment, but not all the rest of the traffic can join segments using different technologies. Disadvantages over hub/repeaters. Delay in forwarding frames. Bridge/switch must receive and parse the frame, and perform a lookup to decide where to forward. Storing and forwarding the packet introduces delay. Solution: cut-through switching. Cut-through switching will begin forwarding the frame as soon as the destination address is identified. Need to learn where to forward frames. Bridge/switch needs to construct a forwarding table, ideally, without intervention from network administrators. Solution: self-learning. Higher cost. More complicated devices that cost more money. Router connects two or more LANs together. Packets sent to remote LAN. Cross-network is segmented by IP address. Connect internal networks to the internet. Need configured before installation. D/my documents /books /Norden I'm /chapter 9 /router.tif. Moving from switches to routers. Advantages of switches over routers: plug and play. Fast filtering and forwarding of frames. No pronunciation ambiguity. Example: router versus rotor. Disadvantages of switches over routers: topology is restricted to a spanning tree. Large networks require large ARP tables. Broadcast storms can cause the network to collapse. Comparing hubs, switches, router. Hub/repeater. Bridge/switch. Router. Traffic isolation. No, yes, yes. Plug and play. Yes, yes. No. Efficient routing. No, no, yes. Cut through. Yes, yes. No.